as Fiona said, this project, Rare Plastic, is about developing an innovative manufacturing process using recyclable reinforced plastic. In this case, it's glass fiber polypropylene for producing wind turbine blades. So I'll just give a project summary of this now. So the agenda for today is I'll give a quick introduction and the background to it, about conventional wind turbine blades and the plastics, or the materials that they're made from, and in terms of how they're disposed of versus where recyclable plastic can play a part in that, especially for a circular economy. Then I'll move on to key objectives of the project, and then I'll give an outline of the work packages, so how this project is broken down into different work packages focus on different aspects of the project. And then I'll go further into the activities carried out for each work package and their respective findings. And then I'll give some project recommendations which we think will be useful going forward, and then also some outcomes and next steps will be covered in the final slide. So, on the one hand, traditional wind turbine blades made from glass fiber reinforced epoxy typically go straight to landfill at the end of life, since the epoxy itself is a thermoset resin with irreversible bonds, making it difficult to recycle. And in recent years, some companies have began to repurpose them as bike shelters or in playgrounds, while others use old blades as feedstock in the cement industry. So that's kind of the limit at how we can get rid of or repurpose traditional wind turbine blades, other than going straight to landfill, as you can see in the photo on the top right. But yeah, both of these are not sustainable solutions in the long term. And in Ireland, this will equate to approximately 100,000 tons of waste going to landfill from these wind turbine blades in coming years. The EU recycling targets require Ireland to make to reduce waste sent to landfill from 22.5% this year to 10% by 2035. So on the other hand, we have the recyclable wind turbine blades, such as those made from glass fiber reinforced polypropylene presented in this project. These can help avoid this issue of waste sent to the landfill. And since the reason they can avoid this issue is they have dynamic bonds in the resin that can be reversed and reprocessed, and thus give the composite a new form of use in a more sustainable way. There are two methods that can be used to recycle the glass fiber polypropylene blades: mechanical recycling, such as compression molding, which you can see on the image in the middle right. This can be used in the automotive industry for manufacturing non-structural components, such as bumpers or wing mirrors. And then there's also another method called chemical recycling, such as pyrolysis, which breaks cured polypropylene resin into a valuable source of hydrocarbons for synthetic gas production. So yeah, there's more of a long-term benefit from recyclable wind turbine blades than there is from traditional non-recyclable blades. So this brings us to the main goal of the project, which is to develop an innovative manufacturing process using this recyclable plastic, glass fiber polypropylene, to produce 1 kilowatt wind turbine blades. So we're looking at kind of micro-scale wind turbine blades. You'd often see them around industrial sites or farmyards or houses. So this is the use case that we use for this project. So you can see an image of the blade shape here. So it's about 1 meter long. So I'll just give an outline of the project objectives. So the first one is to de-risk the new manufacturing process through mechanical testing and assess its environmental impact using the Eire GP, which is the glass fiber polypropylene material, in manufacturing wind turbine blades. The next one is to design, manufacture and test a 1 kilowatt wind turbine blade that's produced from this material in order to further de-risk the new manufacturing processes, to efficiently manage the project as well, along with project resources, to complete the project within the time frame, and effectively communicate the project results and findings as well. And finally, to develop a commercialization strategy and business plan, while building a sales pipeline for the commercialization of the recyclable products. Next, we'll move on to the work package description. So the project is broken down into 5 work packages to help achieve these the project objectives, and thus the main goal of the project. So work package 1 involved project management and communications. It had 3 deliverables: a detailed project schedule, communication, dissemination plan, and peer-reviewed scientific publication. Work package 2 then consisted of commercialization of recyclable technologies for reinforced plastic products. So part of that, 2 deliverables are carried out: a global industry review for customers of recyclable reinforced plastic products, and also a refined business plan and commercialization strategy. For work package 3, we undertook de-risking the new manufacturing process through material testing, and manufacture test specimens for mechanical testing was the first deliverable. Creating a material data sheet for the new glass fiber or the Eire GP material through coupon testing, and we also carried out a life cycle assessment report to see how sustainable and environmentally friendly this new material is in comparison to the conventional epoxy materials. Work package 4 then was the development and manufacture of the demonstrator wind turbine blade using the Eire GP manufacturing process. And there was 3 deliverables in that. So the CAD model was the first one, demonstrator wind turbine blade manufacturing was the second one, and then the manufacturing report itself was the third one. And then finally there was some structural testing of the demonstrator blade itself, where we wrote a test procedure and also reported test learnings and recommendations in the final report. So moving on to the first work package, so the activities and findings of this work package, we created a work package task schedule using a Gantt chart. So this is just to keep on track with keep the project on track and on time. There was a project risk tracker as well created for work package 1. A communication dissemination plan was created, and one of the KPIs was to submit a scientific paper, and which one was submitted to the CRAI, which is the Civil Engineering Research Association of Ireland. Moving on to work package 2 activities. So the global industry review analysed customers of reinforced plastic products. A refined business plan and commercialization strategy summary was then created to analyse key stakeholders, existing and potential customers, and to create a marketing strategy for the recyclable turbine blades. A meeting was also held with SD Wind Energy in the UK to help build the sales and generate interest in using Eire GP in their commercial activities. So the findings from this work package was we identified a number of potential customers during the industry review and development of the commercialization strategy. And we found that they could make use of small-scale wind turbine blades made from Eire GP material. So use cases were also found outside of the wind sector. So orbital marine power, ORPC, were highlighted as potential customers for Eire GP in the marine turbine sector. Eire Composites have previously worked with ORPC's Irish subsidiary, so a relationship with the business already exists. And then in the automotive sector, it's beginning to make a move to using more composite materials in their vehicles, with BMW now making their C-pillars from composite materials, and opportunities to use the new Eire GP material in other car manufacturer vehicles should become more prevalent in the near future. So revenue projections were also made for the Eire GP material in the refined business plan and commercialization strategy summary, and in these projections, sales generated by Eire GP were expected to reach 300,000 by 2025. So hopefully, if we get a push on the commercialization side of things, especially with SD Wind in the wind sector, we should hopefully generate these sales. So moving on to work package 3 activities. Both UD tape and woven fabric test specimens were made. So this is using the Eire GP material. Static and dynamic testing was then performed on them according to the campaigns shown. So you can see the static test campaign and dynamic test campaign on the screen. So we carried out tensile, compression, in-plane shear, fiber volume fraction, bearing, load, and the fracture toughness. So G1C and G2C are fracture tests, followed by some fatigue testing as well, which is just basically the same setup as a tensile test. So as you pull the material apart, but you cycle it from 1,000 cycles up to 1 million cycles or more, 10 million cycles. And then after we carried out the material testing, we also carried out a life cycle assessment for the 1 kilowatt demonstrator blade which was made using the Eire GP material. The LCA was carried out in accordance with the ISO standards, and the LCA compared the environmental effects of manufacturing a 1 kilowatt turbine blade using the Eire GP material to those of manufacturing 1 kilowatt blade using non-recyclable fiber reinforced plastic, which is typically your epoxy resin. So the findings for work package 3, material data sheet was created using the material test results. It showed Eire GP is lightweight and has good mechanical properties such as resistance to warpage, rigidity, and strength. The LCA revealed that manufacturing a 1 kilowatt turbine blade using Eire GP was much more environmentally friendly than manufacturing a similar blade using non-recyclable materials. The Eire GP blade had a much lower global warming potential than the non-recyclable blade, with the Eire GP blade having a global warming potential of just 6.25 kilograms of CO2 per blade, compared to the non-recyclable blades, global warming potential of 30.74 kilograms of CO2 per blade. The Eire GP blade also used significantly less energy to be manufactured than a traditional 1 kilowatt turbine blade. The oven used to cure the recyclable blade used 35 kilowatts of energy, while an oven used to cure a traditional epoxy blade would use approximately 193 kilowatts of energy. So we saw great improvements there for the recyclable material. So then moving on to work package 4 activities. So first, the CAD model of the 1 kilowatt blade was created using SolidWorks. Secondly, the glass fiber polypropylene plies for the blade were kitted. So this is for manufacturing the blade itself. And thirdly, the plies were laid up then into the mold, which you can see in the third image there on the right. And a vacuum bag was the mold itself was encased in a vacuum bag and cured in the oven. So finally, the blade was demolded, trimmed and inspected, and after manufacturing the demonstrator blade, a manufacturing report was written up, which detailed the manufacturing process of the blade, including the tool preparation, kitting, layup, bagging procedure, cure, post-cure inspection, trimming, post-trimming inspections, and packaging of the blade. So we'll see the findings. So from this work package, we manufactured the 1 kilowatt Eire GP wind blade demonstrator, which you can see in the image below, and also the manufacturing report, which I just described. And then finally moving on to the last work package, which involved the structural testing. So first, the structural test procedure was defined and reported. In the report, the blade testing scope was defined. Predictions were made on the blade's center of gravity and the blade's mass, and theoretical results were outlined for the maximum load the blade could experience before failure. An FEA was also carried out on the blade, which predicted the blade's mass, center of gravity, the maximum load that the blade could experience before failure, the maximum tip deflection of the blade before failure, and the blade's natural frequency. So using the structural testing procedure report, the 1 kilowatt demonstrator blade was tested. Static and dynamic testing was performed on the blade to determine the maximum load it could take before failure and the blade's natural frequency as well. So you can see both setups there. You can see that the image on the left is the static testing, and the blade is at maximum load and maximum deflection can be observed. And on the right then we have the dynamic testing experimental setup, which is just, there's an LVDT, which is what records the the deflection of the blade. So you just excite the tip of the blade by just displacing it maybe a couple of mil at the front, at the tip of the blade, and just letting go and allowing the blade to vibrate or oscillate until it comes to rest, and then that's how you calculate the natural frequency of the blade. So then the findings of work package 5. So the results of the test were then used to create a structural testing learnings and recommendations report. So from the mechanical testing performed on the 1 kilowatt blade, it was found that a blade made using the recyclable glass fiber polypropylene could withstand the maximum loads it was expected to receive, and the blade fails at approximately 140 newtons, with the maximum force it is expected to receive only being 69 newtons, so more than twice the load it can take. So that's promising for this use case. And the static test results gathered in their experimental testing match those of the FEA simulation as well, which you can see in the graph on the right, or on the left, sorry. So the experimental and FEA predicted test static test results are in good correlation. So we were happy with that as well. So that's going to be useful for scaling up these wind turbine blades to larger wind turbine blades, and hopefully we can rely on the FEA results to predict what size blades we can reach. So the natural frequency of the blade was found to be 9.79 hertz from the testing, while the FEA predicted a natural frequency of 8.28 hertz. So yeah, both FEA and experimental results were relatively similar, and we can hopefully consider them as reliable. So now moving on to the project recommendations. So after carrying out the project, we found that the main recommendations were inspired by the manufacture and testing of the demonstrator turbine blade. So making changes to the manufacturing of the blades in the future could help further reduce the environmental impact of manufacturing the blades. So these recommendations include performing the kitting of multiple blades in bulk to reduce the number of discarded offcuts. So if you're any kitting, which means cutting up the templates or the plies that you're going to place into the mold, if you only do one at a time, you can typically have a lot of waste around each ply. So the ply is usually in the shape of the blade. So if you have an irregular shaped blade, which is kind of what you can say in this case, where you have a wide root and a narrow tip, a lot of waste can be generated just from kitting one blade at a time. But if you kit multiple blades at a time in bulk, you can fit a lot of them side by side along the glass fiber, the polypropylene roll, and hopefully reduce discarded cutoffs. So it was found that 30% of the mass of the blade was discarded as waste, and hopefully we can reduce that with the bulk kitting. Curing multiple blades in the same oven when batch producing blades, this will reduce cost and the energy consumed per blade, and thus improve its sustainability as well. And then using molds that can hold 2 blades to further improve the heating efficiency of the curing cycle as well. The main recommendations about the testing of the blades would be to test multiple blades when batch producing them, to gather more accurate test results. So the more testing you can carry out and the more data you can get, it would increase accuracy and reliability of results. So yeah, they're the 2 main recommendations from this particular project. And then finally, project outcomes and next steps. So as outcomes and how well we can track the project, we can say that valuable data such as the Eire GP material data sheet which was created, the 1 kilowatt blade structural test results, and the LCA report is a major outcome of the project and can be used to attract both commercial and R&D opportunities. The global industry review showed high potential use of the Eire GP in other industry sectors such as automotive and marine sectors. The success of these outcomes could be tracked by monitoring the number of proposals submitted and one with Eire GP as its material choice, and the revenue generated by sales of the 1 kilowatt blades from commercial contracts. So the project was also mentioned in an ecosystem spotlight segment in PwC's the Irish Climate Tech Opportunity 2023 report on page 41. So This highlights the importance of using recyclable composites in the Irish wind market, and also complements the support and opportunities the EPA provides for such initiatives like the Rare Plastic Project, and also the C2C project that Mark just mentioned as well. So it's great to see those kind of appearances as well. And I've provided a link there in the slide as well to that report. So moving on to next steps. We'd like to penetrate new sectors and markets for research funding in those sectors respectively. And we'd like to secure a contract with SD Wind Energy, so to advance the commercial conversations that have been held with potential customers, and thus securing a contract with them would set Eire GP well on its way to becoming a profitable business endeavour. And then finally, to attend a composite material exhibition such as the JEC show, and we could definitely mention the results of this project as well and how successful they were. So at the moment, there's also some work in progress, which is in other projects that Eire Composites are involved in, and we are obviously taking some of the learnings as well from this project, the Rare Plastic Project, and implementing them in those. So we're developing larger scale horizontal axis wind turbine blades, which is the same as what we described in this project, but they're increased to about 13 meters. And we're also looking at vertical axis wind turbines, which is a slightly different turbine. And we're looking to develop them for both the European and Irish market as part of the Marewind, Reblade and Deep Wind demo project. So if anyone wants any more information on those, the links are provided there to a short summary on the respective websites. So yeah, I think that's all from my side. Thanks for everyone's attention, and I'm open to any questions you may have.